Hello everyone, my name is Matthew Glennon. I'm a freelance math tutor, and today is going to be the third video in my introductory series on factoring, simplification, and distributive property, with today's focus being on how to simplify groups of fractions being multiplied together using something called the cross-cancellation method. This is a really important skill to know, and it helps us simplify expressions before we even do the math behind it. That said, I hope you guys enjoy this video, and always remember, if you enjoy this video, enjoy my teaching style, and would like to work with me on the private level, please feel free to message me and we can make a plan to help you or your child. Thank you all so much, and I hope you enjoyed the video. All right, everyone, we're going to get started with cross-cancellation, which is a process that builds off of our already strong foundation of factoring and simplifying fractions. And I'm going to show what it's used for with an example. So one thing to know about simplifying is that you can do it either before or after multiplying or other steps in mathematics. And I normally really like to do it before doing the operation because the result that you get is probably going to be a lot harder to factor than the fractions that you're given. However, let's look at both of our fractions. We have 5 over 6, which they share no common factors, so we can't simplify that at all. Then we have 3 over 4, which also can't be simplified. However, when we do the multiplication out, we're given 15/24, which you would think since both the fractions were simplified, it should give us a simplified result. However, I'm going to rewrite this as 3 times 5 equals 15, and 3 times 8 equals 24, which means this can be simplified. Even though the two fractions beforehand that were being multiplied can't be, we can simplify the result. And what we would get if we did all the steps out, we'd have 3 over 3 times 5/8, and then that would simplify to 1 times 5/8, which would, of course, just give us 5/8. And if I'm going a little fast, that's because this was covered in my previous video, which covered just how to simplify fractions by pulling out a common factor, the greatest common factor of any fraction, turning it into two separate fractions being multiplied together, and then simplifying that 3 over 3 to 1. And then 1 times any number is just that number, which means our simplified version is 5/8. But what I'm more focused on, even though we were able to simplify it, and that's wonderful, is that we only could simplify it after we multiplied it together. However, it doesn't have to be that way. And that's what we're going to go into today. So it's called cross-cancellation. And it's called cross-cancellation because you can simplify things vertically, say with 5 over 6 or 3 over 4, or you can simplify things diagonally, which means you could either simplify between 5 and 4 or 3 and 6. Or if you had multiple other fractions, what it means is you could take any of the numerators, pull out factors, and simplify it with any of the denominators. Now keep in mind, this only works when there's multiplication. So if you see, say, like addition or subtraction, you will not be able to use this. If you see division, you could do the same process, but you'll have to flip it, use keep change flip, and then, or I suppose for you guys it would be the, no, for you guys it would be this one. I'm looking at my camera now. You would flip this one, and then you could do cross cancellation. However, what we're going to look at is this. So if we look, 5 and 4 do not share any factors, so we're actually going to keep those. But if you look at 3 and 6, they do share a common factor in that 3 can be written as 3 times 1, which that's kind of a given, that's an identity, but it's important for this problem because 6 can be written as 3 times 2. Now, when you're doing this, you don't really have to write the times 1 if you can remember this rule. I like to do it so I don't accidentally put in like a 0 or something like that. And now we can do the same sort of steps that we would do here, except since we can't really write these steps out here necessarily, all I'm going to do is just cross cancel diagonally like this. And then whatever's left over is what you write in the remaining places. So that would be the same as writing 5 times 1, and I'm going to split it across multiple fractions, so it'll be 5 halves times 1 quarter. See? And then if we did all of this out, watch, we get 5 times 1 is 5, divided by 2 times 4, which is 8, which means we get the same answer that we got here. And you might be thinking that this was a lot of extra work to get the same result, and that you could just do it this way, and it would work the same. And for single step multiplications like this, yeah, you could do that. But if you're working with really large numbers, it might be a lot easier to do it beforehand. Or if you're multiplying many, many things together, it might be easier to factor it out before you do all that out. And just to exemplify all of this, I am going to do this really large problem. And it doesn't look very large, it's just one more multiplication, and with kind of bigger numbers if you exclude the 3. But I'm doing this to just prove a point a little bit. So 5 times 6 is 30, times 7 is 210. That is a really big fraction, or a really big number. And then here, we're going to see 3 times 10 is 30, times 42 would be, let's see, 126 times 10, 1260. Now, if you're ever doing something like that and your mental math is not too strong, I definitely recommend using a calculator. That'll help you get the most accurate answer here. But this is our answer, which is this is a big number. This would be hard to factor out all the way, at least in one step. You would probably have to do a whole bunch of littler steps until you finally get your answer. However, with cross cancellation, let's write the same exact problem, except this time I'm going to show you all the steps for simplifying it. So the very first thing that I'm going to recommend doing is first simplify any fraction that on its own can just be divided out normally. So what I mean by that, or simplified normally. So we look 7/10 can't be simplified, 5/42. Hard to see it at first, but since 5 is prime, the only factor it has is 5 and it's 5 and 1. And 42 does not have 5 as a factor, so this one's already simplified. 6/3, however, that would be the same as, and we could do the whole simplification out, but we know that 6 divided by 3 is 2. So I'm just going to write it out this way, where we have 7/10 times, and we could just write 2, but I'm going to write 2/1, so we keep it as a fraction. And then 5/42. And now if we look, all of these fractions on their own are simplified. So now we can try checking for cross cancels. So I'm going to start this first one here. We can see 7 and 1, that can't be simplified. And 7 and 42, well, 42 is a multiple of 7, so we could fix it that way. We could rewrite it so it's 7 times 1 up here, and then 6 times, or 7 times 6 down here, which would look like this. 10, and I'm going to do 7 times 1. And in addition, I'm going to do 2/1, and then 5 over, instead of writing 42, I'm going to write something that is mathematically equivalent, which is 7 times 6, which means we can legally do that, and it's the same as writing just 42. However, now we're going to do our cross canceling. Since we have a 7 here and here, that is all good. Now, one other thing that I'm going to do real quick, and this is mostly to save us time, we could keep going and rewriting it. I'm going to write 10 as 5 times 2 times 1, which, believe me, I am doing for a reason, because if we look up here, we see a 2 here, which would cancel out with a single 2 here. And we have 5 here, which cancels out with this 1 here, or this 5 here. And so we are left with, I'm going to just do the times 1s real quick. We are left with 1 times 1 times 1, which is just equal to 1, and then 1 times 1 times 6, which is just equal to 6. Meaning this really, really, really hard to work with fraction is just the same as 1/6. So learning cross-canceling and how you can sort of just pull apart numbers and factor them in a numerator with any number in the denominator is a really strong skill, saves so much time, and it's easier to work with, which is the really important part. And with that said, that's all there really is to cross cancellation. It's just an extension of simplification, just saying that you could simplify diagonally as well as vertically. The only thing that you can't do is simplifying, I guess, horizontally. So it's not like if there's two factors in the numerators that are shared, you can't just factor those out. Those ones you would just have to stack on top of each other. Now, with that said, I believe that we have wrapped up cross cancellation. Thank you all so much.